Today I hope to guide you through the mole calculation worksheet. By the time you're done, you should have all the correct answers for both sides of this mole calculation worksheet. Before we begin, make sure you have all the things you'll need. You'll need the mole calculation worksheet, a calculator, a periodic table that has polyatomic ions on the back, a mole map, a guide to naming and writing formulas, and probably a little bit of scrap paper to be able to work out some of the things. For the first one, you just follow along with me and make sure you do it how I do it. And on part B, you'll be able to try that one on your own. The way that this mole calculation worksheet is set up is on number 1A, we'll be finding out some information about sodium hydroxide, which we'll use for number 2A, and again in number 3A. So it would make the most sense for me to guide you through all of the part A's. The first thing we have to do is figure out the molar mass for sodium hydroxide. Before we can do that, we need a formula. Sodium has a +1 charge. I know that because it's on the periodic table right there. Hydroxide has a -1 charge and its formula is OH with a negative sign. I know that because it's on the back of the polyatomic ions sheet. Hopefully you can see that it's only going to take one sodium and one hydroxide in order to make sodium hydroxide. So the correct formula is NaOH. The next thing I need to know is the molar mass. I need to know what 1 mole of sodium hydroxide mass would be in grams. Check the chart. Sodium has a mass of 23 grams. Oxygen has a mass of 16 grams. And hydrogen has a mass of 1 gram per mole. Adding them all up, you will get 40 grams. 40 grams with the correct units. I'll need that information as I move down the sheet. I'm going to go to number 2A. It says I need to change 10 grams of sodium hydroxide into the number of moles. I start these the same way. I start writing down what they gave me, 10 grams NaOH. And then I get ready to multiply by a fraction. I use the mole map to figure out what to put on the top and the bottom of the fraction. You can see that I know grams and I need to get to moles. So I throw the mole map into here. I know grams, there's the scale, and I need to get to moles. Stay on the right hand side of the road. 1 mole goes on top, the molar mass goes on the bottom. 1 mole of sodium hydroxide goes on top, and a molar mass of 40 grams sodium hydroxide goes on the bottom. That 40 grams was the molar mass. It goes there. I double check to see that grams of sodium hydroxide crosses out. And when I put that into the calculator, 10 divided by 40 I will get 0.25 moles sodium hydroxide. I'm going to go to the next part A because the next part A at the bottom is based on the same formula unit, sodium hydroxide. 3A, calculate the number of grams in 1.5 moles of sodium hydroxide. I start writing off what they told me, 1.5 mole. I just abbreviate it by dropping off the ES. Sodium hydroxide. I get ready to multiply by a fraction, and now is when I need to consult the mole map. I know moles and I need to get to grams. So I start in the middle of moles and I need to get to grams. That means 1 mole goes on top and a molar mass of sodium hydroxide goes on the bottom. Let me backtrack. Didn't make sense. I need to get from moles to grams. From moles to grams, I have to stay on the right-hand side of the road. The molar mass goes on top. 1 mole goes on the bottom. 1 mole sodium hydroxide goes on the bottom. The molar mass of 40 grams sodium hydroxide goes on top. 40 grams sodium hydroxide. Now I can see that it truly does cross off and cross off. 1.5 times 40, 1.5 times 40, 60 grams sodium hydroxide. You'll move along and you'll try letter B. The next video below will guide you through it.